Hello everyone to my channel MATLAB. In this new video to the playlist of MATLAB, we will reduce the noise from a signal using a low pass filter in MATLAB. Okay, as you can see in this script of the video third, when we put a noise to our sine wave signal, and now we will try to bring it back as clean as possible. So first of all, with the same, or let's do another script. Okay, you can click on the plus button here or here, and we will declare our time frame as always, step time 1. Then we will declare our frequency, then we will declare our signal sin 2 pi multiplied by the frequency and the time frame, just like that. So this is our original clear signal. Then we will add a noise to it. Let's put noise like this. Okay, yeah, like that we add a noise. Then we will declare our noisy signal, just like that. Our original signal plus the noise 1. Okay, just like that. We will run it now, and we need to save it. Let's save it like video 4. Okay, sorry, this is from the previous one. Right, again, this is it. Okay, so now we will plot the noisy signal. Start by typing figure, then plot the time frame, then our noisy signal. Okay, then you will do this grid on so that we can see x and y lines inside of the figure, just like that. We will do x label for time, and y label for amplitude, just like that. And the title, we will put the title like this: noisy signal. These steps we did it in the previous video. If you didn't watch it, go and see. So the noise, we will see it now. I'm very sorry. What is it? I think I did a mistake here. Where did I did it? Okay, so let's run it again and see. As you can see clearly, the noise makes the signal harder to observe. Okay, so our next step is to create a low pass filter that allows the low frequencies to pass and reduce the high frequencies noise. We will start by declaring the sampling frequency. Let's call it fs and put this like that. Then the cutoff frequency. Let's put like 10, and we will need to declare this our like that equal Butterworth. This is Butterworth method. Then there are many methods, you can try them like that. Then the frequency cutoff, so like that, by the sampling frequency divided by 2, just like that, and we'll click run. It didn't, so just like that. Okay, now we need to apply the filter that we did, this filter that we did to our noisy signal. We will start by typing the new signal x filtered equals like that. This is all functions in MATLAB. You just need to memorize it and work with it, just like that. Okay, just like that. Now we need to plot our filtered signal. Let us just copy this, okay, so that we can reduce the time of the video. Figure here x. Now change this to filtered. Okay, let's do it red. It's okay. Now like this, filtered signal, and leave everything like that. We click run, and as you can see that the most of the noise has been removed. Look, this is the difference between the noisy signal and our filtered signal. Okay, when you look closely, it's not 100% filtered, okay, but there are improvements from this to this. So this comparison clearly shows how filtering improve the signal quality. Let's just do a trick here and change the cutoff frequency from 10. Let's put 3. Okay, and run it again. As you can see, so what you clearly observe, reducing the cutoff frequency remove more noise, but it can also distort the signal. So this is all for our video. In the next video we will visualize this filtering process using Simulink, which is here, Simulink, instead of coding in editor. If you like the video, please like and subscribe and leave a comment about questions or mistakes or whatever what you want. Okay, so goodbye and peace.